Hello everyone, welcome to Calculus Lecture 11. And today we're going to be talking about the fundamental theorem of calculus and using it to solve some definite integrals. All right, so we've talked about this once before, but the fundamental theorem of calculus has two parts. So sometimes people's definitions vary. I'll just teach it to you the way I've been taught this. So part one, if we have some function f as a continuous function, and then we define capital F to be the integral from a to x, so where a is some fixed point of f of x dx, then f prime of x, capital F prime of x, is equal to little f of x. So basically we just use this definite integral to construct an antiderivative. So that's pretty cool. We also have the second fundamental theorem of calculus, and this is going to give us a way to find the definite integral. So part two is that if we have some function f and g is an antiderivative for f, then the integral from a to b of f of x dx is the difference of the values of g at those points. So g of b minus g of a. And so we're going to use this to solve some definite integrals. So let's do some examples. All right, find the area under the curve of f of x equals 4 sine x between 0 and pi. So I'll pause for a minute, see if you can use this to find this area. So you're going to need to set this up as a definite integral, and then find the antiderivative, and then take the difference of the values at the start and end points. All right, so the first thing we want to do is find this g. So that's just an antiderivative for f of x. So this is the indefinite integral. So we want g of x equals the indefinite integral of 4 sine x dx. All right, and so we know that the derivative of cosine is negative sine. So I'm just going to pull like a negative 4 out. So this is negative 4 times the integral of negative sine x dx. And the integral of negative sine x dx is cosine x. And we don't need our plus t because we're going to subtract and it's going to go away anyway. And so now to find this, we're going to just subtract the values at 0 and pi. So the integral from 0 to pi of f of x dx is going to be g of pi minus g of 0. So negative 4 cosine pi plus 4 cosine 0. And what are these? Cosine pi is negative 1 and cosine 0 is 1. So this is going to be 4 plus 4, which is 8. And that's our final answer. Now, I have a question. So what if instead of going from 0 to pi, I flip the values? And I said go from pi to 0. Now, this might seem weird to you because normally you don't go backwards. So by definition, if we have a and b, and then we asked for the integral from b to a of some function, so we flip it and b is greater than a, this is by definition the negative of the integral from a to b of f of x dx. So we just compute the integral the normal way, but then add a negative sign. So if we did this, then the answer would end up just being minus 8. All right, so let's do another problem. So evaluate this definite integral from 1 to 3 of x squared plus 2x plus 5 dx. So I'll just pause for a minute, so try to work it out on your own, and I'll give the answer in like a few minutes. Okay, so the first thing we're going to do is find an antiderivative. So that's going to be your indefinite integral. And we'll just do this using the power rule. So we're going to get x cubed over 3 plus x squared plus 5x. All right, so this is our g of x. And now we're just going to do g of 3 minus g of 1. So let's find that out. So what's g of 3? G of 3 is 3 cubed over 3 plus 3 squared plus 5 times 3. So that's 27 over 3, which is 9, plus 9 plus 15, which is 33. And then g of 1 is 1 cubed over 3, so just 1/3, plus 1 plus 5. All right, so that's going to be 6 and 1/3. And then we can just subtract. We're going to end up with 33 minus 6 and 1/3, which I think turns out to be 26 and 2/3. And so this is going to be the final answer for our integral. All right, let's do some more practice. Let's do the integral from 1 to 2 of 3e to the x plus x squared dx. Once again, I'll pause for a few moments and then give the answer. Okay, so first we need to find an antiderivative. So our g of x here is going to be the indefinite integral of 3e to the x plus x squared dx. So we're going to have the e to the x stays e to the x. Plus, and then the antiderivative of x squared is x cubed over 3. And then we're going to have to evaluate this at 2 and then at 1 and subtract. So we're looking for g of 2 minus g of 1. So what's g of 2? So g of 2 is 3e squared plus 2 cubed over 3, so plus 8 over 3, minus g of 1, so minus 3e minus 1/3. So that's going to be 3e squared minus 3e. There's not much simplifying there, plus 7/3. And that's our final answer. All right, let's do another one. And we're going to do this integral 2 ways, actually. We're going to do it once using the fundamental theorem of calculus and once by drawing it and finding the area, because this is going to be linear, so we're just going to be looking for the area of a triangle. So here's the question. Evaluate the integral from 0 to 4 of 8 minus 2x dx. So see if you can solve it using the fundamental theorem of calculus, and then we'll also do it conceptually later. Okay, so let's do this. The first thing we want is an antiderivative, so we're gonna again set g of x to be our integral, the indefinite integral of 8 minus 2x dx. And that looks like it's going to be 8x minus x squared. Now we'll just subtract at 4 and 0, so g of 4 minus g of 0. So g of 4 is 8 times 4 minus 4 times 4. And then minus g of 0, but g of 0 is just 0, so we can ignore that. So the final answer is just going to be 16. Now let's try doing it the other way. So we're going to draw a graph and then just find the area. So over here, the x-intercept is going to be at 4, 0, and the y-intercept is going to be at 0, 8. And so the graph looks like this. Yeah. And we're finding the area of this triangle. So this is going to be base times height over 2. So 4 times 8 over 2, which is 16 again. So we got the same answer both ways. Let's do another one like this. Let's just have f of x be a constant function. F of x equals 3. And we want to find the integral from 1 to 5 of f of x dx. So try and do this both ways. I'll just pause for a minute and then give the answer. All right, so let's first find our antiderivative. So the antiderivative is just the indefinite integral of 3, which is 3x. And so we're going to do g of 5 minus g of 1. And that's going to be 15 minus 3, which is 12. And then the other thing we could do is just draw it. So say this is 1 and this is 5. So this length here is 4. And the function is constant at 3. 3. And so the area we're trying to find is a rectangle with width 4 and height 3. So the answer is going to be 4 times 3, which is 12. And so we get the same answer both ways. Let's do one more. Let's do the integral from 0 to 2 pi of sine x. So again, we'll do this both ways, once by drawing it out and once using the fundamental theorem of calculus. Okay, so let's do this. So again, we want our antiderivative, g of x equals the integral of sine x dx. And what's the integral of sine? Well, the integral of sine is negative cosine. And then we're just going to evaluate. So we're going to have negative cosine 2 pi plus cosine of 0. And this is just negative 1 plus 1, which is 0. Now here's the other way we could have found this integral. We can actually draw this function of sine x. So this is 0, this is 0. This is pi, and this is 2 pi. And the way this graph goes, it goes up. It has a curve up here. All right, this is plus 1. And it has this downwards curve. And these actually are exactly symmetric. So the point is that the positive part is exactly the same as the negative part. So we can see from the graph that the integral is 0. Let's do one more that we can only really do using a graph. So I'm going to draw a function, f of x. And the question is to find the area under the curve. On the interval from -2 to 6. So here's the graph. So over here, it's just going to be constant at at 2. And then it's going to increase to this point. So this point over here is 1, 4. And then it's going to go horizontally until 3, 4. And then it's going to decrease. And this last point is 6 comma negative 2. So the question is to find the area under the curve between negative 2 and 6. So this integral. So once again, I'll just pause for a moment and see if you can figure this out. You're just going to need to find the area of this part and then subtract the area of that part. Okay, so I'm going to split this into a bunch of rectangles and triangles. I'm not sure if this is the most efficient way to do it, but it will work. So I'll have this square. I'll have this rectangle. Here a triangle and a rectangle. This triangle I'll leave as is. And then we'll have this triangle. Remember, this triangle will have negative area. All right, so this has area 4. This has area 2. This has area 1. This has area 8. This has area 4. And this has area negative 1. So then we just add all these up. So we're going to end up with this 1 and negative 1 cancel. So we're just going to have 4 plus 2 plus 8 plus 4, which is 18. And so that's going to be our integral. Let's do a couple more problems for practice. Let's do the integral from 0 to 1 of x to the 7th dx. The integral from negative 1 to 1 of, let's do the no, let's not do the natural log. Let's do e to the x minus 2 dx. And finally, let's do the integral from 2 to 3 of 3x minus 1 dx. So I'll just pause for a few moments so you can try and work that out, and then I'll go over the answer. All right, so let's discuss the answers. So for the first one, we want our antiderivative, g of x equals the indefinite integral of x to the 7th dx. And so this is going to be x to the 8th over 8. And we're just going to go from 0 to 1. Remember, this notation just means we're going to evaluate at 1 and then at 0 and then subtract. So this is going to give us 1 over 8, and then at 0, it's just 0. So our final answer will be 1 over 8. All right, the second one. Again, we want our antiderivative, g of x. And this is going to be, we're still going to have our e to the x, and then we're going to have a minus 2x from this term. And then we're going to go from -1 to 1. So the final answer is going to be e to the 1 minus 2 minus e to the -1 plus 2. And so at the end of the day, this gives us e minus e to the -1 minus 4. All right, and then for the last one, we again just take our antiderivative, g of x. That's going to equal so 3x squared over 2 minus x. So 3 halves x squared minus x, and we're going to go from 2 to 3. So let's work that out. But 3, we're going to get 3 halves times 9. So that's 3 squared minus 3. All right, and then minus the value at 2. So 3 halves times 4 minus 2. So this works out to 27 halves minus 3 minus, once we multiply that, that's going to give us 6 minus 2, so that's 4. And so the final answer we're getting is 27 halves minus 7, which should be 13 over 2. And that'll be our answer. So before we finish for today, I just talk a little bit about what we'll be doing next time. So next time we're going to talk about methods for integration. And there are two main methods we'll need to learn. So one is called U substitution, which is similar to the one for derivatives. We're going to make a change. We're going to have something equal u, and then change the integral from dx to du, and then solve in terms of that. And then the other thing is going to be something called integration by parts. Now, unfortunately, integrals aren't as reliable as derivatives. With derivatives, we can just use the chain rule, and it'll almost always work. Now, with integrals, a lot of the time you'll try something and it just won't work. And then you'll have to try something else and see if that works. And sometimes integrals can be pretty tricky and annoying to solve. But yeah. These methods can be used both for definite and indefinite integrals. No, I always prefer using it for the indefinite and then applying the fundamental theorem of calculus. I just find that easier because then if you use this for a definite integral, you have to also worry about changing the limits when you change your variables. With an indefinite, it doesn't really matter because you switch back before you actually plug in numbers. So thanks for watching.